Okay. Everyone, please get yourself ready. We start the lesson now. So first of all, I want to remind you we have a test on Wednesday about the book 3B, the whole book. And it would be 45 minutes with 8 MC questions and 3 short questions. So everyone, please use single line paper. Prepare single line paper and stationery. You can open your book to do, okay? But it's meaningless if you cheat. The score is not really important. I think the most important thing is you get yourself prepared and try the questions with your own ability, right? And you need to write down all answers on the single line paper. And after 45 minutes, you need to take the picture and convert that into PDF file to submit through the Google Classroom, okay? So that is the arrangement on the Wednesday test. So make sure that you get yourself ready for the test. And yeah, I will remind you again tomorrow. So today we spend some time on the revision of the whole book 3B, and especially I will highlight some key core concept or core idea that will be covered in the test. Okay, now so I have prepared these notes for you, and I already uploaded in the Google Classroom. So make sure that you read that carefully. First of all, now I'm not going to go through these one by one, point by point. I will just extract some important notes from it. So time by time, I will also need to make use of the whiteboard to elaborate a little bit. Now first, in the first part, chapter 4, we usually talk about the transverse wave. So you'll be given a diagram like this. Okay, let's say you have a wave, and always look at the x-axis. There will be two types of axis. One is XCM, which is this distance and displacement relationship. And for all these type of axes, you will see there will be a time, let's say it's t is 0 given to you. Okay. Now, so first question I would like to ask: would you be able to read the information from this graph? There will be two information you should be able to get. The first one is amplitude. This is the amplitude. You can read that from the height of the peak, from the equilibrium position. Okay? So this is the first thing you should be able to do. And the second thing is you should be able to read the lambda, the wavelength. The wavelength could be the length of the 1 unit of the wave. This is the wavelength. Okay, so ask yourself whether you can get these two information. Okay, so that is the first information you should be able to tell. Okay, secondly, if you have another graph which is t equal to that is x-axis is time. So let's say you have a graph like this, maybe like this, okay? So what information we can get from this graph? In fact, what you can get is, first, you can get also the amplitude, right? But now in this graph, you would not be able to get the wavelength. Instead, since this is talking about time, so what you can do is to find the wavelength. Let's say now this is 1 unit of wave, right? Not wavelength, period, sorry. This basic unit with the x-axis, which is time, is actually telling you the period of the graph. Okay? Now, so be able to read the information. And now I would like to ask a question. This graph actually refer to which particle on this graph? how to handle that? This is a high order question. Like if you're given a ST graph, S displacement position graph, and also you're given a displacement time graph, how would you relate them together? Okay, which particle? I mean, this graph is which particle? Now, to handle that is actually not difficult. You need to gather the information from these two graphs. First of all, at t equals 0, look at this, at t equals 0, it is at equilibrium position, right? So, refer to this time to 0, you know that the possible points are these 4 points, 1, 2, 3, 4, or maybe 5. These 5 points are possible for this diagram. Can you follow? And secondly, you notice that as time increase, it goes downward, right? It goes downward. So among all these 5 points, 1, 2, 3, 4, 5, what are those going down? So we may just make use of what we have done before. We join the wave shift to the right a little bit so that you may see that this point is going downward. I use rectangle better. This one will be going downward. This one going upward, downward, upward, downward. So the possible points are only these three. Okay? This is how we relate the displacement position graph and the displacement time graph. Is okay. Now, so make sure that you can handle this. This is the first part of the question. All right, so I will erase the board. So you may check with the notes by yourself later. Okay, this is the information I just talked about. You can shift the graph a little bit to find out the particle is going up or going down. All right. So I don't go through that one by one. So now I will come to another situation, and we talk about the refraction. This one. Okay. Now, so what is the condition for refraction of water wave? That is when the wave travel from one medium to other medium. And in water wave, is talking about the deep or shallow region. Okay, for deep region, it goes faster. Okay, and shallow region is slow medium. Now, first you need to be able to remember this relationship, and then we make use of this relationship. When the speed is faster, its wavelength should be also larger. And then its angle will be also larger. So that's why from this graph, you may see that in the deep region, it has larger lambda compared with this, okay? Together with the angle, I will draw a normal line. This is the normal line, right? So which is the angle 1, and this is the angle 2. So you may see that the angle theta 1 should be also larger than theta 2. So that is the refraction part. You should be aware. Is it okay? No response, huh? Everyone keep silent. Okay, anyway, let's go on for the next one. It's about diffraction. All right, diffraction. Sorry, got stuck up. Okay, good. Now for diffraction, you may check with this information, these 3 graphs. They have different type of, different intensity of diffraction effects. So among these, you may see this is the strongest diffraction effect, and this is the weakest diffraction effect. We may compare the diffraction effect by the change of direction. So you may look at the first one. It only bend a little bit at the edge, but for the last one, it becomes something like almost a circular wave, right? So this is how we compare the diffraction effect, and the diffraction effect depends on 2 factors. The first factor is larger lambda. You may check, compare these 3. The larger lambda always giving a bigger diffraction effect. Okay? And the second thing is, where's my word? Do you see my words? Here, yeah, here. Second factor is the gap, the width, the gap, sorry, gap width, not width, gap. The gap width for a more narrow gap width. If the gap width is smaller, the diffraction effect will be also stronger. Okay, so you may compare these three. The larger lambda and smaller gap width is actually this one. So it gives the largest diffraction effect. You may see that if originally it go forward, it bend much more. For this angle is smaller, right? This one is smaller. For this, it goes much far away. The range is wider. So this is the largest diffraction effect. Okay. So question we ask here: how would the diffraction effect being changed? You may compare these two factors. Always look at these two factors. Okay. Okay. Let me clear this. Another one is interference. For interference, it has to be having two sources. And when two waves with the same coherent signal, coherence means they have the same frequency and same phase difference. So they will reach the same point, overlapping each other. And definition for the path difference is the longer path minus the shorter path. And we may make use of this path difference to find out whether it is equal to n lambda or n plus half lambda. So for this case, n lambda, it will give constructive interference. And the other one will be destructive interference, right? So what are the difference between these two types of interferences? For the constructive interference, its amplitude will be double. And for destructive interference, its amplitude will be cancel out, almost cancel out. It will be greatly reduced. So that would be the difference. So, but the key is always to be able to read this path difference and then compare that with the wavelength is usually given. So you may find out the n is n integer or the factor is a half number, so that you can tell whether it's a constructive or destructive interference, and also be able to understand the result of that. It will result in a stronger or a weaker vibration. All right. So this is a diagram showing the lines joining all the same path difference. I will call that anti-loadal lines or loadal lines. Okay. So you may refer to the notes. Okay, now this one I want to spare more time on that because yeah, there will be a question asking that. Let me show you what is going on. So let's say we have a vibrator. You oscillate up and down, connecting to the electricity, and there is another end is connected with a string like this. For the stationary wave happens, this length should be somewhat related to the possible wavelength. The first order is like that, right? So in this case, L should be equal to lambda over 2, right? This one is actually showing half of the lambda. Oh, I got L1. Oh, sorry. Fooling around, Mr. Lau. I mean lambda 1. Oh, the second possibility is like this. So in that case, L is equal to lambda. Okay? It is exactly equal to 1 lambda. And the third one is like this. So how many lambdas are there? It's 1.5 lambda, right? 1.5 lambda. I can call that 3 lambda 3 over 2. right? 1.5 is equal to 3 over 2, etc. So in fact, I can have a general equation. This L should be equal to n lambda n divided by 2. You may check with the first one. Put 1 here, you put 1 here, you have this equation. You put 2 here, you got this, right? You put 3 here, you got the third one, etc. So basically, you may make use of that to find the possible lambda and the possible frequency of the stationary waves. Okay, so you may understand what's going on. If you increase the frequency, you will have this change. And up to a certain frequency, there will be first order, second order, third order of stationary waves. Okay? Higher frequency means more loops. This is, I'll call this loop, 1 loop, 2 loops. This one is 3 loops. All right? That is stationary wave. And besides, let's go back to the notes. Wait. Oh, sorry. Okay, please spare some time to study this difference between the stationary wave. Standing wave or stationary wave are actually the same, just a name. Sometimes people call it standing wave or stationary wave. You may compare the difference among these. Understand? So this is stationary wave. So I will jump directly to these Young's double slits and also the diffraction grating questions. So this is the most important part in the test on Wednesday. Okay. So the first thing is Young's double slit experiment is just no more than just the interference pattern of light interference. So in the previous part, you see the same graph. Actually, this is usually we would make use of water wave or sound wave by showing this graph, because those wavelength is something visible. Our eyes can see. It's usually few cm. It's something we can actually observe easily. Okay. However, for the light, you know, the light having very narrow wavelength, our eyes would not be able to see that at all. So in that pattern, we can still use this to show what's going on, but actually it's not possible. It's not up to scale, because there should be many wavelengths within this distance. The graph will not be able to show you clearly. It's just like a schematic graph. It's not really true. It's not really real thing, right? I can actually call that it's fake. Where's my pen? Don't trust this graph. It's fake. Fake news. Fake graph.
Like Mr. Lau.
Fooling around, fake graph. But it helps you to understand what is going on, because at the end, those maxima are the bright fringes. We call it bright fringes. And what you need to do is to know the fringe with fixed separation, delta y, for only for Young's double slit, not for water wave, not for sound wave, not for diffraction grating. This delta y can only be applied for the Young's double slit experiment. So you need to read the question. If you see this word, you go directly to this equation. Okay, you just substitute the information there to find the unknowns. Okay, then you need to be able to identify the unknowns D, lambda, and A. Okay, there are 3 unknowns, right? What are they? D is the distance between the slits to the screen. This is the D. And lambda is the wavelength of the light. It can be ranging from 400 nm to 700 nm. The longer one is red, the shorter one is violet. And the last one is A. A is called the slit separation. Okay, slit separation. It's there already. See? This is slit separation. So from these three information, the first one, second one, and also lambda, you can find this delta y. Okay, this is delta y, delta y, delta y. All these are evenly distributed. Okay. So be able to make use of this equation to answer the question. Okay. Now let me erase the board and ask you a question. Now this is a blue light, right? It has a certain delta y for green color. What if I change it to red light? I change it to red light. What would be the change of this pattern? So that's why I remind you this. Within this visible light range, red light always having a larger wavelength, right? So be aware of that. It's not given, but that is something you should be able to remember. So yes, very good. Separation is bigger according to the equation here, right? If lambda increases, that means delta y would also be increased. So this is how we apply this equation, right? And you may also use another way to answer that. Because it passed through a small slit, right? It's actually also related to diffraction. So for the larger wavelength, it will be having a stronger diffraction effect, so that the wavefranges will be also more separated. So both of them, one of that is quantitative. We use calculation, right? The other one, I use the diffraction to explain that. Both of them are actually telling you the same thing, right? The red one will be wider. Okay, so it would be one MC question asking that exactly the same thing, changing color, how would be the change in the fringe separation? Okay, now so let's go on to the second one. Diffraction grating. So for diffraction grating, I may need to use a whiteboard. Okay, now so I will send the light towards a diffraction grating. Alright, this is diffraction grating. The diffraction grating is not the same as the Young's double slit. The Young's double slit has only 2 slits, okay? And the diffraction grating is having many slits within a certain width. So that's why when you see the pattern on the screen, it's no longer having the evenly distributed pattern. It will be something like a bright spot only, and then there would be another bright spot and the other bright spot. I call it first order, second order, and it should be symmetrically on the other side, first order. Actually, I'm telling you the test questions. Pay attention. All right. So when we have this thing, I may also join the lines towards. Where's my? Oh, what happened? Sorry. I lost my pen. Not the physical pen. I mean. Oh, I forgot it. Use this now. Can I draw straight lines? Here. Oh, sorry. I forget it. I just use this draw. I tell you in advance, my drawing will be very accurate because I can't find the tools for drawing straight line. Okay. This is the angle for the first order bright spot. Okay. And there will be another one. Second one. This is theta 2. Okay. Now, so we can set up equation according to the one given from the formula sheets. Okay, the formula would be this one: d sine theta equal to n lambda. Okay, so let's say I just randomly give some number. If theta 1 equal to 30 degree, okay, and then theta 2 should be equal to, let me calculate a bit, sorry. Oops. So what should be theta 2? I may try to make a question like this, okay? How can we find the theta 2? Now, notice that the light slanting to the grating will be having the same wavelength. So for two angles, I can set up two equations. The first equation is d sine theta 1 equal to 1 times lambda, right? The second equation is d sine theta 2 equal to 2 times lambda. Now we are looking for the theta 2, right? We can calculate that basically by using the first equation divided by the second equation. So when I divide that, I can cancel the lambda, cancel the d, so that's cross multiplication. 2 sine theta 1 equal to sine theta 2. So it's 2 times 0.5. Because sine 30 is equal to 0.5, is equal to sine theta 2. Okay, after calculation, theta 2 equal to 1. Oh, sorry, 90 degree, I mean. Is it possible for 90 degree? If it's 90 degree, basically the light will go so far away because it turned at 90 degree, it would not be able to reach the screen. So this is a fake bright spot. It's not possible to be there. You won't be able to see the second one, basically. So this is how we calculate the theta 2, all right? Yeah, this is how we handle these parts. Another thing I would like to highlight is, let me erase something here. I can ask the question in the other way. Okay, if I have this angle, let's say I change not 30 degree, I make it like 15 degree, or I have this angle, and then I tell you the information about D. Now, this is one of the questions on the test. Let me finish that, hurry up. Usually I will give you like a 1 cm, 300 lines. If I give you this information, you can find the D by using 1 cm divided by 300, which is 0.01 divided by 300. It's okay. So you may calculate this by yourself, which is 3.33 times 10 to power negative, is it negative 6? Maybe 5. Let me calculate. D or A, or both are okay. In the book, it use D, but it's okay. It's just a number. You know the number. You know the letter means the separation of the line separation. Okay, you may calculate this one, right? So after that, you may just the question can ask you what's the value of this lambda. So what is lambda? You just put all the numbers there. 3.33 times 10 to the power negative 5 times sine is given, right? 15 equal to first order 1 times lambda. Then you may find out the answer by using this method. Okay, now so before the end of the lesson today, be aware of this equation. There are 4 unknowns. First one is the line separation. You can calculate by using this method. How many widths are divided by the number of lines? And this is sine theta, the angle at that order. And also the number of order. If it is for the first order, you may put 1. Second order, you may put 2. And the last one is lambda. Usually, the question will give you all information except one, and then you should be able to make use of the equation to find the unknowns. Okay? Now, so that's the end for today. You may find these notes from the Google Classroom. Okay? And tomorrow I will continue for the remaining questions that would happen in the exam. Okay. So if you have questions, you may stay behind. If no, you may leave. Bye-bye.
Bye, sir. Thank you.
Bye-bye.
Bye, sir.
Bye.
Bye, sir.
Bye,
Bye.
sir.
Bye-bye.
Sir, what's the use
Yes.
of learning this?
Can you louder? I can't hear you.
Sir, what's the use of learning this?
Very useful.
So how am I gonna use this in my life?
You mean the defense grading?
The whole wave chapter.
The whole chapter. Now, it's something like basic thing about wave, right? And we make good use of the diffraction grating. I think the most important thing here is the diffraction grating because it helps us to find the wavelength of different waves.
Sir,
Different,
Newton created
different source will be emitting different type of light. By looking at the wavelength, we can tell what material it is.
Sir, did
You
Newton
will learn that
create
in book
this?
E2.
Sir, did Newton created this useless?
Sorry? Louder.
Did Newton created this also?
Yes. Newton is one of those who is related to the optics.
I hope
He's just genius, you know. But you know, he's actually not a good guy.
Why?
He make use his power in the Royal Society. It's a scientific society. You know, to make some people into very bad situation.
Oh.
Yeah, just like he think he's the king in that. He dislike a guy called Hooke, and then he make Hooke in a very poor situation.
Sure, but Einstein is much smarter than him.
I think Einstein is much better in his personality.
Why, sir?
Both Einstein is the one who advocate the peace in limiting the nuclear weapon.
Sure, but he was the one who created nuclear weapons. Like the idea.
He's not the one who create that. He just generate a concept, but people make use of that to make weapon. So he's not really happy with that. Not only this, if you read his writing, he has a lot of idea about how people should communicate or should work together to give a better world. Yeah. He's great because of this, not only the scientific discovery. Okay?
Okay, sir. Bye, sir.
Okay, take care. Bye-bye.
Bye, sir.